Assalamu alaikum dear students. Today we shall discuss the another form of the straight line that is called normal form. Suppose we have a non-vertical line which is given with the following data. First one is length of the perpendicular which is called normal from origin to the line, that is length of the perpendicular from the origin to this line is given. Angle which normal makes with the positive direction of x-axis is also given. So what is normal? Now if we consider a curve like here in this straight line, like this straight line, this is straight line. Now if we consider any point on it, suppose this is a point on it. Now tangent at this point coincides with this line, because for straight lines tangent coincides with the given line. Now from a point, if we draw a perpendicular from this point at a point where we have a tangent, then this perpendicular is here called as a normal. This tangent as well as this normal should lie on the same plane. So this is called as a normal or simply perpendicular. Now here we have two things. One, the length of this perpendicular and the angle which it makes with the positive direction of x-axis. Here this angle, or we simply can say that this perpendicular lies in 4 of the quadrants. So this means that 4 situations arise. First one, where this perpendicular lies in first quadrant, that is from origin OA is the perpendicular or simply the normal. Its length is given and its length is b. Suppose let us assume that it makes an angle omega with the positive direction of x-axis. So here this omega is here acute angle. Now from this point A, that is foot of this normal, we draw a perpendicular on x-axis, that is AM. Similarly, if omega lies in second quadrant, then the graph of the line is this, with the length OA equals to P, and from A we draw a perpendicular AM. Similarly, if it lies in third quadrant, omega is here, the measure of the omega is greater than 180 and less than 270, and OA equals to P, which is same throughout. And in fourth case, if it lies in fourth quadrant, then the measure of the omega is greater than 270 and less or equals to 360 degree. From this foot of perpendicular we draw a perpendicular on x-axis, that is AM. Now if we consider, in this case, if we consider a triangle OMA, given we have two things given. One is P, the length of this hypotenuse, and second one is the base angle, that is the angle which it makes with the positive direction of x-axis. So in this triangle, clearly OM means base equals to P cos omega, and perpendicular MA or AM equals to P sin omega. Hence the coordinates of this point A in each case equals to P cos omega and P sin omega. Now here this omega is the angle which it makes with the positive direction of x-axis, which implies that the slope of this normal equals to tan of omega, because here omega is the angle of inclination of this normal, which implies that slope of normal is equal to tan omega, which is simply, hence the slope of this given line or the required line, that is line L, is minus 1 upon slope of this normal, because both are perpendicular to each other. Hence by the condition of perpendicularity in terms of slope is that slope of line equals to 1 upon minus times 1 upon the slope of the normal, which is tan of omega, or simply minus cos omega upon sin omega. So we have for this line we have two things. One, the point through which it passes, and second one is the slope of the line. So by using the slope point form, we simply get, which is y minus y naught equals to m times x minus x naught, where this x naught and y naught is the point through which this line passes, and m is the slope of this line. Here point this line passes through P cos omega and P sin omega, which implies that x naught equals to here P cos omega and y naught equals to P sin omega, and its slope is minus cos omega upon sin omega, which implies, substituting in this equation, we simply get y minus P sin omega equals to minus cos omega upon sin omega into x minus P cos omega, or by cross multiplication it is y sin omega minus P sin square omega equals to minus x cos omega plus P cos square omega. Shifting the terms, that is x cos omega plus y sin omega equals to P sin square omega plus P cos square omega. P is common, take P common, which implies that it is sin square plus cos square omega, which is 1 by identity. Hence we simply get P in the RHS of this equation. So x cos omega plus y sin omega equals to P. Hence this is the required form of normal form of the line. So in normal form we have two things: one, the length of the perpendicular, or the length of this normal from origin to the line, and second one is the angle which it makes with the positive direction of x-axis. If angle is omega, length is p, hence the normal form is x cos omega plus y sin omega equals to p, which is this one. Like if we consider an example, we have to find the equation of a straight line such that normal from origin is making an angle pi by 4 with the positive direction of x-axis with length equals to 5. So this means that here omega is pi by 4, p is here 5. So substituting in this, x cos pi by 4 plus y sin pi by 4 equals to 5. Cos pi by 4 sin pi by 4 is 1 by root 2, which implies that it is x plus y equals to 5 root 2. So this is the equation in normal form of a straight line whose normal from the origin is making an angle pi by 4 with the positive direction of x-axis and whose length is 5 units. Now simply start the exercise. First 5 questions are easy. You can simply substitute the values in first 3 forms which we already discussed. Now question number 6 of exercise 10.2 is, we have to find the equation of the straight line which is intersecting the y-axis at a distance of 2 units from origin but above the origin, and making an angle of 30 degree with the positive direction of x-axis. So this means that this is the required graph of the line. Here it intersects the y-axis at a distance of 2 units above the origin, which implies that it passes through point 02, because any point on y-axis is of the form of 0y, hence its coordinates are 0 2. Also it makes an angle 30 degree with the positive direction of x-axis, which implies that its angle of inclination is 30 degree, hence its slope is m equals to tan 30 equals to root 3. So using slope point form, because point is given, slope is given, so using slope point form, x naught equals to 0, y naught equals to 2, we simply get x root 3 minus y equals to 2. So this is the required equation of the line, of a straight line which intersects the y-axis at a distance of 2 units above the origin and making an angle of 30 degree with the positive direction of x-axis. Question number 9. Find the vertices of triangle PQR with P of 2 1, Q equals to minus 2 3 and R equals to 4 5. So 3 vertices are given. We have to find the equation of median through R. What is median? Median is the line drawn from vertex to the midpoint of opposite side. So that line which is formed by joining the midpoint of one side and the vertex of an opposite vertex, that is simply called as the median. Firstly we will find the median of PQ, because we have to find the equation of this median through R, which implies that we firstly find the midpoint of PQ. So by section formula, midpoint of that is A is given by minus 2 plus 2 upon 2, 3 plus 1 by 2, because by section formula. So hence the coordinates of this A, which is the midpoint of PQ, is 0 2. When we join AR, this AR is the median from R, that is from vertex R. Now clearly this median passes through 2 points, one A whose coordinates are 0, 2, second one R whose coordinates are 4, 5. We have to find its equation. So by using 2-point form, that is line equation of line passing through points x1 y1 and x2 y2 is y minus y1 equals to y2 minus y1 upon x2 minus x1 into x minus x1. So when we substitute here, x1 is here 0, y1 is 2, x2 is 4, y2 is 5. So substituting and by multiplication we simply get 3x minus 4y equals to minus 8. So this is the required equation of this median from R to the other side of this other opposite side. Now another question, that is question number 11. Find the equation of the line through point minus 3, 5. That is this line, given line passes through this point 3, minus 3 and 5. And this line is perpendicular to the line joining the points 2, 5 and minus 3, 6. So this means that we have to find the equation of line which passes through minus 3 and 5 and which is perpendicular to the line joining the points 2, 5 and minus 3, 6. Now here slope of this line 2, 5 and minus 3, 6 is given by difference of y coordinates upon difference of x coordinates, which is simply minus 1 upon 5. Let m be the slope of the given line, that is which passes through minus 3, 5. Now this line is perpendicular to this line whose slope is minus 1 upon 2. So by condition of perpendicularity we simply get m equals to minus 1 upon the slope of this line, which is minus 1 upon 5. So simply m equals to here 5, because lines are perpendicular. Also it passes through minus 3, 5. So by slope point form, y minus y naught equals to m times x minus x naught, which is simply y naught is here 5, x naught is here minus 3. So by substitution we simply get 5x minus y equals to 20. So this is the required equation of line which passes through minus 3, 5 and which is perpendicular to the line through the points 2, 5 and minus 3, 6. So thank you.